Welcome back to the Tube Barn. This might be a little weird video today. I'm feeling very sick, but I wanted to get this video out, so it could be a little hodgepodgey. I don't have time for the craziness, so we're just gonna get into some basic shit. So today, we're gonna be delving into the actual circuit of the preamp section. I'm also gonna show you some other items that I'll be using within this build. Now, if you don't know how to read schematics, I suggest you learn to some extent, because it's going to help you when dealing with certain designs. The way I learned how to read a schematic is a friend of mine bought this old Vibrolux, and he needed to fix it. We never really got to fix it. I didn't know much back then, but I had the schematic and I had his amp and was able just to look at the schematic and check the wiring, boom, boom, go back and forth. And I really learned to read them. It's not that hard. You can get, like old Fender has really good schematics that have both the wiring diagram and the schematics. So if you can get a hold of one of those, I might try to put a link for this video in the description, and you could go ahead and look at that. But I'm going to try to go slow if you don't understand schematics, so it makes sense. My schematics are very linear. That way it makes sense. You look at old Marshall stuff, sometimes that stuff can get crazy, and even I'm like, what the hell is going on here? So let's get into it. Now, let's just get into the preamp section. I'm not going to show you the power amp section right now, because one, I'm going to probably mod it a little bit, and there's got a few things that are missing, and I'll do that on another video. So let's just deal with the preamp. Now, just so you see this here, that doesn't matter. That's just because this is from a program called Spice, LT Spice, to where you can simulate circuits. So there's a few things in here that just do it like, you know, I have it in here for that. Like this is just the AC signal. So just pretend that this is your guitar and there's the cable coming in to your amp. Now, your input of your grid here needs to have a ground resistor. Sometimes it is the volume pot, the gain pot, whatever you want to call it, because that is technically a resistor. It's a variable resistor. So when it first comes in, you have your ground, which is your 1 million ohm ground. Now, the first one, you always see it has 68K. The reason why that is because that is about the signal or the level of resistance that blocks out radio frequency. So if you have an amp or know someone with an amp that's got radio issues, you may want to check if it has the resistor or if it's shorted to just straight. It's just shunted out. Or maybe it needs to be shielded. I don't know, but that's always a good place to start. Now, you got your signal into your grid. As we discussed on the two videos ago, it comes in, this is a plate follower stage. Comes in a grid, goes out the plate, continues on. So you got your cathode resistor here, which normally you see about 1 to 2.7, 1.8, depending on what you're doing. I'm not going to talk about the reasons for that right now. My brain is just not working. So follow schematic unless you're designing stuff. And if you're designing stuff, well, you should probably read a little bit more than I'm going to show you, because remember, I'm Tube Amps for Dummies, and my brain is barely functioning today. So, remember, we had your cathode capacitor. Of course, this should have a little plus here to show the orientation, you know, positive going up. And remember, as we said, the cathode resistor more or less overrides the negative, or I should say the feedback that the resistor is doing here, and gives that signal back. Like this is a 1. This is a 1 UF, so it's going to give back a little bit more high end. Now, as I stated, I'm going to be using a cathode switching circuit to where I'll be able to switch from, say, the 1 UF to, say, I think I'm doing about 220, 250, something like that. You'll see that in a lot of Marshalls and mixers, where you get that full-bodied flavor going up into it because you got that high capacitance. Now we're talking about this stuff. I'll be using quite a few of these. This is a relay board, and this can be for multiple voltages. There's relays. A lot of the easy ones to get are 5 volts. They're actually easier to use for the fact that that's what you're going to get out of a lot of your already supplied center taps, such as your heaters, depending on what your voltage on those secondaries are and what you have available. The difference is I have an LED. The ones I use I've cabled so I can put it in the front of the chassis. So this resistor here, going from the source of your voltage to your LED, will change depending on the voltage of your supply. I'm using a 5 volt and I got the red LEDs or green. The reds and the greens are fairly the same, so the resistor I don't believe is too much difference. So I got to look into that, but they seem to work. Now if you're going up to like a 24 volt, you're going to have a much different resistor on there. Now your relay board always has a diode in between the positive and the negative of the of the supply for your relay. That's a safety feature. I'm not going to get into that. The way this generally works when it comes to functioning is you have your voltage, it's going into your LED, it's going into your relay, and then it says foot switch. For this, at least this board, the way I function, is that's going to go to your foot switch or a switch on your amp, and what it does is it just connects it to ground. And that way it has a path to ground, and then it turns on and it functions. What I have here, and unfortunately, I don't have a single pole double throw relay board, which is pretty much what I would use in this, but I'm not going to have another one made. So half of this is not going to be used. Depending on the orientation of your relay, one will be your path that's always connected, and the other two will be the ones that it switches to. One of them is naturally connected when off. So when you're figuring out, say you're going to do this cathode situation, you want your 1, you want your 220 or whatever, which is the one that you normally want to have on? It doesn't really matter. You can change back and forth, but I figure, why always have your relay on when you don't need it to? Whatever makes it work less, it means it'll last longer. They last pretty long, so it's not really a big issue. But it doesn't hurt to make your stuff last longer. It's always going to be connected to the cathode here, in the center one. And then you're going to have your cathode capacitors connected to these. One here, one here. And then when it switches, it'll be switching back and forth like that. Now to stop it from popping, because that's what capacitors will do when they're connected like that, we're going to put some resistors from this one to this one, and from that one to that one. There's an argument on what it is, but I'm going to use a couple million ohm resistors, between 2 and 5. I'm going to play around with it and see what works. And that's what we're going to do with that. Have any questions? Ask in the comments. That's what they're there for. Now, moving on is another fun part that I'm going to bring that thing back out, but one of his friends too. You got that, it comes back in. Remember we said it comes as a plate follower, it comes back out. Now the difference is when I stated that this is going to have gain and master switching. Now that's why it looks like this. Is I'm going to split this into two. Here's a gain pot, here's a gain pot. Of course, we have the capacitor that removes the DC. That's what that does. They're going to be the same. I'm not looking for a major change in tone. And you have your resistor, which works as more of an attenuator, as I said, voltage divider, working with the gain pot. Now, I changed it up a little bit. This one, I figure, a little bit more gain moving through the system than that one, because this is going to be the channel, I should say the gain option That's going to give it a bit more oomph. I think I've decided to bring this down to a 220 resistor on the final one, but I think I'm going to keep this as a 330 picofarad. Maybe it does something, maybe it doesn't. Remember, these resistors do take away your top end. The larger the resistor, the farther lower in the tone that it takes away, which is why you use these capacitors to jump that missing signal over the resistor. Now, if I have a 220 resistor and a 330 picofarads, I'm not sure what that's going to do. We're going to find out. Why? Why not? You know, that's why I do this. Play around with shit. So, anyways, that's what I'm doing. And, of course, this isn't connected. Like I said, this is a SPICE schematic, so I didn't want to build a whole circuit with the relays. I actually don't even know how to do that. I just have no intention of doing it. It's too much pain in the ass. So, it will come out here. This won't be connected. This and this will go into the relay. And like I said, sometimes you only want to use half. Now the problem is I used to do it, and sometimes I still do, is I would put the same thing. You have your masters here right after the tone stack. We'll get to this tone stack in a minute. And so you use that side for your gains and that side for your masters or your volumes, depending on what you want to call it. But because I've decided to put my masters post phase inverter, that doesn't work. I'm now having to use 2 relays instead of 1, which I don't care for, but it is what it is. And the reason why I don't care for it, because if one of your relays fails, but the other one obviously isn't failing, then one's going to turn on, one's going to not turn on. So when you have your gain on your quiet one, barely any gain, but you have it wide open on your volume to let that signal through, that's fine. What happens if this relay fails, but the one switching the gain to all the way on or close to it, and then you have this? You've basically just, it's going to get real freaking loud. And probably not what you want to happen. Hopefully that won't happen live, because that would be a problem. So it is what it is. Now, I made this one a while back. I made this for a 2-channel amp. This is just to switch from channel A to channel B, channel 1, channel 2, whatever you want to call it. Now, the reason that I use 2, you think, well, do you really need that? And the answer is, for me, yes. Because I built an amp, that one over there actually, and later we're going to rip that apart and we're going to make it new. That was an old early attempt. Has some issues. I want to use this on it. Now, the reason why is because, one, you want to make sure that when you turn one off, that your grid is grounded. I say, if you look at a schematic of an amp, when it's not on, you want this straight to ground. Not the resistor ground, you want to straight ground your signal. Which is why when you have your jack, on your input jack, you want to have it to where it shunts to ground. When there's nothing in it, it shunts to ground. If not, your amp will hum and it doesn't like it too much. With this, you ground, depending on which one's on or which one's off, you ground the off one. Remember, you only have one jack. And because you have your cable plugged into it, it's no longer shunted to ground. So you need to ground the front of it, of the one that's not off. Now, for me, I like to have, say it's coming, okay, not this, we're not dealing with that, we're dealing with the ultimate signal here, whatever. The ultimate signal from it, if you don't have that, then you have that. Is your ultimate signal coming out of it, switches. Now, I want to ground that as well, because these capacitors, they're all charged up, and you could get some popping when you change. So you ground it. There's a whole bunch of resistance in there, so it's fine. So it'll slowly discharge those capacitors so you don't get any pop when you're turning it on. So you have one that switches back and forth what it is, and you have one that's grounding it, and you have one that's switching, and you have one that's grounding it. I actually haven't used this one yet. I'm looking forward to it, but I'm going to use this on this amp because of what I'm doing. Like I said, I can't use one, I have to use two. Well, technically it's going to be 1.5 of this because I could be using a single pole. I don't need both, but I want to use this because this board turns on both of them on and off at one time. And so it's just easier for me to do it like that. Remember when we showed the diode in between the two, I just put the one diode here. This is to ground. You can't see it's actually ground. That way I'm just using one diode for both. Yeah, so that's all good. Now let me show you another relay board. Or let me just actually talk about, we just talked about two channels. One channel is easy, 2 channels is super easy. It's pretty much one stop on and off. If you want to go to 3 and more, that's extremely difficult. When I was first trying to build a 3 amp many years ago, I couldn't figure out how to do it. There's literally nothing on sale. I've seen forums and forums and forums and forums of people like, how do I do it? And they're using all these crazy ass techniques. So I had to create my own device. And what I did, there's a couple examples of this device. Now, this is this section. So that is generally that. What it is a PIC controlled relay board. I should say a relay controller board. Now, I used this, I didn't really like the way it functioned. Well, no, it functioned just fine. I didn't like the way it messed up my layout in my amp, and so I didn't like it. So that's that. Now layout we're going to get to later is very important. When I start working on the amp, we're going to talk about layout. It's extremely important because this is in one spot. When you have 3 channels in your amp, having this in one location really sucks because you're cutting cross wires. So what you do is I created this. This is also a relay board, but it's a transistor controlled relay board. What happens is this side gets hooked to foot switch. This side goes to your relay board. It says LED here because I originally created this to where I was going to use this in the amp and this in a pedal board so you could see the lights on the pedal board. It would just seem easier than running a whole bunch of cables that would probably die because DC doesn't travel well. So instead of using the LED here, you would just send the one side over to your relay board. Now, what's nice about this is, I'm going to put my glasses on so I can see this thing, is this your PIC. It comes from here. It goes into here. It controls all this. And how it works is similar to this. Everything runs in and you connect it to ground and it turns on. It's the same thing. But what you can do with this, if you have, you can either run both your 5 volt, because this runs off 5 volt, both your 5 volts to here and here, or you could run this on a different voltage of a relay, 12, 24, whatever you want. But your PIC controls here, and what it does is it just basically triggers the it triggers the transistor to turn on, which sends everything, which opens up to ground, and so once you have a connection to ground, everything turns on. Boom. So you have this and 3 of these. I also have one that can do 8. So I haven't used that one yet. It seems a little crazy. But so yeah, so that's how I deal with multiple channels. This one right here, that's what works in it. I have this in there, this and 3 of these boards in there. So that is how that works. I like little crazy things. And now, so while we're getting to there, your power regulator. This is my 5 volt power regulator. Now, you got to remember when you're got your center taps on your secondaries. I know I say that a lot, center tap on the secondary, but really, it's really freaking important. It is. You can burn shit up, all this stuff. So it's a very major consideration when you've got your power transformer. Do I have secondaries? Do I don't have secondaries? So it depends. If you don't have center taps on your secondaries, like I said, I'm sick, my brain's not working. If you have center taps or not on your secondaries. Now, one thing is true, reason why I use this, because the transformers I used have the 2 different heater secondaries. So I got the 6.3. So you got your 6.3 going in here, one side. And so I only use, because I have a center tap, I only use these 2. I don't use these two, because it's connected to ground. If I do that with a center tap, this will pretty much just fry out. These diodes would completely cook out and short. So it's a standard regulator. You get it in there. The capacitors, like we discussed, are smoothing it out. So 3300. You can use whatever you want. If you get higher, it's harder to get things to fit on these things. The reason why it looks like that, you just can, either be one that's radial, or you can't remember the other name right now. Brain is not working. So the ones that laying down, the one that's standing up. There you go. So the cool thing about this one is with the 5 volts, you can get a 5-volt regulator that works by itself. Now, with the higher voltage, you end up with a Zener diode here. And your Zener diode controls your voltage, what you're looking for. So when you get into 12-volt regulation, that's fine and all if you're trying to, say, do 12 volts on your heaters. But trying to find a Zener diode or a regulator that does 12.6 is freaking, I mean, without spending a lot of money, I can't do it. I haven't found it. So what I'm hoping for is when I do a 12.6 DC, I'm hoping to get a Zener that maybe has like 15% freaking accuracy. That's what it says, 5%. This is variance. I'm hoping I'll just buy some and find one that's, it's a little hot. Cool. These ones will be silicone. These are basically going to ground to kill the high frequency noise that you don't want on your electronics. And then of course you have another UF. This is a electrolytic, and that's just to give it just a little bit more smoothing on the end. And that's what it is, and it goes out your 5. If you're going to use a bunch of relays on your 5 volt, I would suggest using multiple regulators because they get a little weak when it comes to it. Trying to figure if there's something else I want to say about that. No, that's good. Let's move on. Now, I forgot to mention this when recording the video, but if you do not have the higher secondaries for your heaters and it's just your standard 6.3 heaters, then you may need to get something like this, which I believe uses a positive and negative voltage, and they're able to get that 5 volt. Because you're not going to be able to get it off of those standard heaters. It's just not going to regulate. You're never going to get those 5 volts. It won't be stable. So look into something like this. So when it comes out of your relay, it goes into the grid of the next stage. Now, you don't have to worry about the grounding because your pot is acting as the ground. It's a standard plate follower. This has a 12K resistor on it, which is acting as a cold cathode, especially since this one is going to be an 820. I'll put a link on more of a description of what that does. It's more of a tonal feature. You got your standard, remember your plates. This is your plate resistor. Your standard is going to be 100 unless you're doing something a little different. It's always going to be 100. Comes out your 0.022, remember it's a guitar amp. And then it's going to go into an attenuating circuit. Was 470 is very standard, but I've decided I'm going to let a little bit more through, so I'm going to change this to 1 million just so I'm shoving it a little bit more through. I'm just going to overdrive this thing and see what happens. So remember, 470 picofarad. This is your capacitor that is jumping that higher frequencies over it so you don't lose it through that. And here we got your old cathode follower. Now, A little different. And when you're dealing with wiring diagrams and stuff like that, especially the one that I'm going to show you later when I start building, some of the stuff is done and wired on the tube. This is one of those things that is literally wired on the tube. And of course, I'm going to have to show you this later because this is not the updated version. I have some safety stuff when it comes to a diode here and a resistor. It's just kind of a startup safety feature, because when you hit it real quick, it kind of can beat up your tube. So it's a safety feature, which I'll show you later. But what happens is when you wire it, I'll bring my power, my DC voltage, and connect it to the pin on this tube. And remember, the triodes are two, it's like saying two tubes in one. Now, they have two halves. So this is going to end up one tube. So wiring on there is really easy. So you bring this onto your pin. What I'll do is I'll connect this resistor from here to the other pin. That way it's connecting on it. And what happens is it comes out here. It comes out the plate. Goes directly on the grid. There's no capacitor. There's anything like that. Like I said, there's some safety stuff that's not showing it. I'll show you later. Goes in there, and it's got to come out the cathode. Now, you'll see I had this at 100. You'll see this in a lot of amps, old amps. You'll see this 100. Now, the reason why it's 47 is when you're overdriving it, it's bringing the crunch a little less fuzzy. So you're going to get more crunch and less buzzy fuzz on it. I'll put a link on that as well, just kind of showing you how that works. And that page actually shows the safety features on here. Remember, I've talked about Valve Wizard. I like his stuff. He's got some really cool information. It's available online if you really want to learn. Check his stuff out. I'm not gonna say simplified, but it's not difficult to understand. And he's got nice pictures and diagrams too, so that helps. Now, this is a 3-stage. 1, 2, 3 stage. Uses 4 halves of a tube. So it's actually, this is 2 tubes. 1 tube, and then 1 tube. What I do in choosing tubes is I like to use the Electro Harmonex on my first stage. I wish I could just have a half that great, mainly because they are low noise. Use whatever tubes you want. If you find a good one and you got the money to pay for the crazy stuff, but with this stuff, I don't buy really expensive tubes because I'm not going to buy a whole bunch of tubes I have, but just sit over there in the corner and look freaking pretty. But if you want, you get your Electro Harmonex here. It's quiet. Apparently it's going to be this one too, even though it is what it is. But if you have multiple channels, you could say, oh, well, I'm going to use the half of this for one channel and half of that for the other channel. And that works out real good. Then I got my JJs, which I like because they definitely have more drive to them. And when you buy your tubes, we talked about match tubes. You can also have your preamp tubes checked, and you can prioritize. Do you want low noise or do you want more gain? Now, I've had amps to where I switched the Electro Harmonex with the JJ, and you can definitely hear the difference in increased noise. Not significantly, but noticeable. And depending on how loud it is, you're like, is it good? Is it works for you? Me, I'm a little picky, and I like my things very, very quiet. So that's that. I hope I'm making sense. Like I said, my head's not on straight. You go, excuse me. Then goes in your tone stack. Remember, cathode followers are great for powering tone stacks. Now, one thing I want to mention, and if you are able to get those schematics that have the wiring diagram, one thing you're going to notice is the way that this is set up is the way it's actually wired. If you go into every freaking schematic, they're going to have connected. They're all going to be connected. This is connected to that. This is connected to that. Everything is freaking connected. But that's not how they're wired. So you're looking at these amps, And you wire like that, and I said, that sucks, I don't like that. And it's like, why isn't it the same? Why does it sound the same? Because it's not how it's wired. So that's one thing to consider, is the different ways to wire your tone stack. But every single schematic is going to have that connected to that and that connected to that every freaking time. It's very much annoying. Even though you go to the second page of the PDF, check out the wiring diagram, going, that's not how you're wiring it. So why the hell do you freaking do it? Seriously, someone tell me, why do they do that? I find it extremely annoying. There's also a school, this is again a little bit off subject, but not the same. People say guitar amps don't need a mid knob. Which, you tell me. That's all up to you, your amp. So what they'll do is they'll just put a resistor here instead of, which I'll probably try to get a picture of that. There's just a resistor here, and there isn't a pot. So that way you just have bass and treble, and that's pretty cool. This is usually a linear pot, and these are audio pots. A little difference in the way they work. We'll get into that later. Now this is the difference. This is what I've done in the past, as I put my two master volume pots at the end. This one, that's what it's like. Now, when I come, I'll try to get a picture of that so you can see something, is when I decided to do that, to put the volume, master, whatever I'm gonna call it, past the phase inverter, which is past here, it's over here, it's over there. I'm so I can move this, which is over here. So you're gonna put a freaking pot here, pot here. So I had to change it because the way that I did the plate, the face plate, is I put the volume, the gains and the volumes as 4. But because I'm doing this, it really doesn't work. So I've changed it on the amp that I'm going to build, and I have the gain here and the master way at the end. And that has to do with the layout, because you're trying to run these things, these wires, way far away. So I'm like, this doesn't work. So like I said, layout. We're going to discuss layout because I need to lay out this amp. I haven't laid it out yet. And layout is a major issue. Before you buy your faceplate, figure out what it is you're doing and building, because I suggest knowing what's going to happen. And if you're going to use a faceplate, order the faceplate. And when you order the faceplate, only have them put pilot holes in it. Because sometimes you'll order pots and the threads on the pots and the this and the that, they're different. So you have inconsistent holes. Also, you use your faceplate as a stencil or template to drill out your pan. So before you even get your faceplate, like I had a faceplate for this amp, I decided to change it. Now I had to buy a new faceplate. So I have a faceplate that I don't need anymore. So there's that with faceplates. I don't know. That's what we're talking about today. I'm going to keep this short. I just wanted to make sure I got a video out. Please ask questions, comment, have like and share with your friends would be good. New channel. And if you have any real comments about, if you're one of those people that actually knows what you're talking about, and you have some comments, let me know. But there's that. I got a video done. See you next week.